I am recording the DASYLab Basics training in order to provide additional training material on the internet. This is a class without students, so it will move a lot faster. While you are viewing the various videos associated with the class, feel free to pause, look at it on your own computer, work with it on your own computer. So this is intended to be a training class. If you have any questions, of course, you can contact Measurement Computing. So this is DASYLab Basics. This is normally a 2-day class. I am going to be presenting it in 8 modules of material. Before you start the class, you really should ensure that if you're working online, you have online access. Review the Measurement Computing DAC Handbook. The URL for it is listed here. You need a Windows computer running Windows 7, 8, or 10, and you should download and install from the Measurement Computing website the DASYLab evaluation. Optionally, the MCC DAC software, which is the drivers and support for measurement computing devices. You can use an MCC DAC device, the demo board, or even your PC sound card. The class that I'm going to be giving is going to be using a Measurement Computing USB 201. You can use other devices, but they are not going to be covered in this class. So Module 1, this is the introduction, DASYLab Basics, Introduction, Installation, and Overview. When I'm giving the class in person, this is a lot of talk, before we get to doing hands-on. Logistically, each class consists of 8 modules, about 90 minutes each in person. Right now they're running to be about an hour each because I don't have the normal give and take that you have in a class. The agenda for Module 1 is a brief introduction, an overview of data acquisition, and then the introduction to DASYLab with its requirements and its environment. Think of Module 1 as vocabulary. It's introducing you to the concepts of the program without actually doing anything with the program. So my name is CJ Butler. I've been working with DASYLab since we first introduced it to the United States back in the early 90s. I have a lot of experience. I work with a lot of different customers. So I've been teaching the DASYLab class probably since 1996, on and off. And that's one of the reasons that I am tasked with bringing it online. The objectives of the course are to provide a fundamental knowledge of DASYLab. By the time you finish this class, you should be able to perform basic application development, and we will also talk about some areas of advanced application development. The basic principles of navigation, data logging, working with DASYLab triggers, taking a look at the mathematics and statistics functions available within DASYLab, and a quick look at signal analysis with frequency analysis, windowing, and filtering, and an overall overview of functions in the program. Advanced topics, depending on an in-person class, would include strings, variables, actions, events, layouts, the DASYLab control sequencer, the state machine, and the script module with Python. Some of these will be broken out as separate either modules or separate training videos completely. The concept of this class has always been that the student has a computer in front of them running DASYLab, and that you're able to follow along, not just watch, but follow along, so that the concepts can be implemented. Now, certainly in an in-person class, there is give and take with the student if something doesn't work correctly. With a video class, you'll be able to rewind a little bit and review some of the things I did. I'm trying to teach this exactly the same way I do in class, where I will be explaining what I'm doing as I do it. If you haven't done this already, download the DASYLab software and install it. You have to be an admin to install the hardware and software. For measurement computing, you need the Measurement Computing Instacal and Universal Library. We optionally have taught with the National Instruments NI-DAC MX or the Data Translation Open Layers. We don't cover those two drivers in this video class. When you install DASYLab, if you don't already have a licensed version, select the evaluation version. That will give you 28 days from the time you first run DASYLab. Select the drivers at the time of installation. The sound card is automatically selected, and you can choose Measurement Computing, National Instruments, the IoTech drivers, data translation drivers. You'll see that there are other drivers available. These are the drivers that Measurement Computing typically sees and supports. The resources, the Measurement Computing website is www.mccdaq.com, and then if you put a /DASYLab, you will go to a general DASYLab index, which has product information, purchasing information. You can request technical support. There's hardware and software information, links to manuals, videos, technical and application notes, and customer success stories. The Measurement Computing site also has the software and driver downloads for Measurement Computing, IoTech, and data translation. In addition to the information that's available directly on Measurement Computing's website, there is also a knowledge base, kb.mccdaq.com, where you can review various articles, technical notes that have been written for Measurement Computing, IoTech, and data translation products, as well as DASYLab and DASYLab examples. If you are an interactive kind of person and you want to use an online forum, forums.ni.com, DASYLab is listed under additional NI product boards in the community, and it's monitored by Measurement Computing, National Instruments, and system integrators. In Germany, there is a www.dasylab-forum.de/forum with German, some English, and there's also a French variant in there. So these are our two different ways of talking to us online. And of course, at Measurement Computing, you've got the ability to request technical support, and you can either work via email or phone with us.
What is a data acquisition system? A data acquisition system measures, stores, displays, analyzes information or data collected from a variety of devices. This distinguishes a data acquisition system from something such as a standalone oscilloscope or a standalone analyzer. Most measurements require a transducer or a sensor to convert the measurable physical quantity into the electrical signal that the computer can use. Examples, of course, include temperature, strain, acceleration, pressure, vibration, sound, humidity, flow, level, velocity, charge, pH, and chemical composition. We're only limited by the type of sensor. DASYLab doesn't actually care what the sensor is. You're going to be using a sensor that converts its physical value into voltage. And then within DASYLab, representing that voltage as the physical value units.
Another view on the same thing, a data acquisition system is a sensor that's connected to some sort of signal conditioning, which is connected to an analog to digital converter and thence to the PC. The hardware is typically sensors, signal conditioning, the DAC device, and the PC. And the software, certainly DASYLab for data acquisition, but there are other products out there, data translations, QuickDAC, National Instruments Measurement Studio, NI LabVIEW, Microsoft's Visual Basic, and others. And many vendors include out-of-the-box software, Measurement Computing's DAC-ME, Tracer DAC, IoTech's DACView. For post-processing, we find an awful lot of our customers still use Excel, but NI's Diadem, MATLAB, Datasp are all packages that you would use once you have acquired and stored your data and you need to do post-processing. The DAC hardware that's supported by DASYLab includes, but is not limited to, measurement computing, data translation, IoTech, many Omega Engineering devices, National Instruments devices, and a longer list of devices. There is a driver list at our website, as well as when you look at the installer, you can see device drivers that are also available. The common interfaces range from PCI to USB to Ethernet connected with some limited number of wireless devices. In addition to dedicated data acquisition type devices, we support general purpose interfaces. You can connect to a device over the serial port. Doesn't matter how the serial is connected, whether it comes in through Bluetooth or as a hard wire, or as a RS-232 to USB, as long as the COM port is supported, then DASYLab will see it as a serial device. We also support a limited number of general-purpose Ethernet devices. We support a wide variety of Modbus connected devices via Modbus RTU and Modbus TCP IP. We support the CAN bus primarily through National Instruments CAN, but also through Exact and Vector CAN devices. And we support IEEE 48 or GPIB. We recommend that you use an NI or NI compatible GPIB card to work with DASYLab. The last general purpose interface is OPC. OPC is a client-server technology where you set up the server to talk to your hardware, and then DASYLab acts as a client to get the data from that server. So the DASYLab software, and these words are pretty specific at this point. DASYLab is Microsoft Windows-based software. So it is not Linux, it is not Apple, it's not iThing or Android or Raspberry Pi or Arduino. It is very specifically Microsoft Windows-based software. You'll use a supported device to acquire data. You can manipulate the data. Manipulation can include things like scaling, statistics, formulas, averaging. You can make decisions on the data. You can use trigger conditions, preset conditions. You can log the data to the hard drive, to the network, directly to Excel or to a database. You can display the data graphically with a list or with a digital or an analog value. And you can also use DASYLab to control external devices. So the DASYLab basics, the system requirements. I'm going to go through these, and then I'll bring DASYLab up on the screen and walk you through the DASYLab environment. So the system requirements, versions, add-ons, the work area, modules, wires, appearance, and menus. So this is just going to be a quick 50,000-foot overview of the DASYLab environment. System requirements. We require a mid-range PC. That term has enabled us to stay current as PCs improve. You don't want the PC that you would use perhaps for 3D modeling, but any PC that you would use for standard 2D type computation. We'd need at least 2 GB of RAM, and we need 1 GB of free disk storage, of which half of that has to be on the system partition. The video, a minimum of 1024 by 768. Windows 7, 32-bit or 64-bit, Windows 8.1, 32-bit or 64-bit, or Windows 10. DASYLab does require a mouse, touchscreen, or other Windows pointing device. You cannot manipulate DASYLab with just the keyboard. We no longer support older versions of Windows. A lot of customers ask us what we recommend. We recommend an excellent mid-range to high-range PC. It doesn't need to be a gaming computer, and as I say, it doesn't need to be a 3D modeling computer. The high-end graphics cards, DASYLab isn't going to take advantage of those. You need 2 or more gigabyte of RAM. Or realistically, with Windows, you need at least 8 gigabytes if you're going to do more than 2 things at once. And any more memory than that gives you space to do other things while you're working with DASYLab. DASYLab is not ever going to use any more than 4 gigabyte of RAM because it continues to run as a 32-bit application. So any additional RAM is room for Windows and other Windows applications. Your data storage depends on your measurement. If you're doing low-speed measurement, you don't need much in the way of hard drive space. If you're doing high-speed data acquisition, if you're sampling 50,000 or 100,000 samples per second, then you're going to need appropriately more hard disk space to store that data. We do recommend that you get a high-resolution monitor with a graphics board depth, color depth of at least 24 or 32-bit. That's a given now with most monitors. 1024 by 768 or better screen resolution. And with DASYLab 2020, we support multiple monitors. We've also improved our ability to handle the high-resolution monitors, a 4K type monitor, for example. So you have more flexibility in the type of monitor that you can work with. And we support all Windows printer and plotter devices. So DASYLab versions. DASYLab comes in 4 developer versions and then a runtime version. The developer versions start with DASYLab Lite, basic data logging with a maximum of 16 analog inputs, a limitation of 64 connecting wires, a limited number of modules in the module list, and a single layout. DASYLab Basic takes away the limitations of analog inputs and wires. Most features are enabled except the ones that work with the action module. So the action module is not included in Basic, and any module that requires the action module, such as message or ODBC, won't be available. It also has a single layout. DASYLab Full is the robust, sort of standard version. It includes all the features, all the standard features, including the actions, the control sequencer for worksheet test management, up to 200 layouts, and it does not include DASYLab Net or any of the other analysis add-ons. DASYLab Pro includes all the features in full, including some additional modules, signal analysis, and some other toolkits. The DASYLab evaluation version is DASYLab Pro, so you will see those additional features if you're using the evaluation version. The class can work well with DASYLab Basic up until we start talking about multiple layouts and the action module. And at that point, you would need DASYLab Full. The DASYLab Runtime version is a workaround to the fact that DASYLab is not a typical programming environment. You cannot create an executable from your DASYLab worksheet. The runtime environment is a no development version of DASYLab where you can run any existing worksheet. You can run any application that was created with Lite, Basic, Full, or Pro. It's not a true runtime in the sense that it does not create an executable, but rather it's a limited version of the full program. DASYLab Pro includes a sequence generator, which allows you to create a custom sequence signal composed of ramps and sine waves. It includes advanced frequency analysis. Functions are the transfer function, convolution, block weighting, octave, third octave analysis, a universal filter, and others. And these supplement the standard FFT and filtering functions that are included with DASYLab Full and Basic. It includes the rainflow statistical counting algorithms, and it also includes a feature that we used to call DASYLab Net, high-speed network input and output, and DASYLab remote control, but it's DASYLab to DASYLab only. You need 2 or more cooperating copies of DASYLab with unique serial numbers to be able to work with DASYLab Net. So let's talk about the DASYLab program elements. We've got menus, module bars, function bars, status bars, browsers, consoles, the work area, the layout window, and the display window. And what I'm going to do now is move over to the DASYLab program to show you these different elements.
When you initially start DASYLab after installing it, it will look something like this. DASYLab has got the standard title bar, it's got a menu bar, it has a custom function bar, these are shortcuts. It has on the left the browser where you can browse for modules, black boxes, favorites, or the navigator. This empty area in the middle is the work area. This is where you're going to be putting the logic for any worksheet that you create. The bottom of the DASYLab screen includes information for diagnostics. The lower left is referred to as the console window. This initially starts out with a list of the files that DASYLab loaded when it started up. And for example, you can see the last two files. One of them is the data translation library, and the other one is the measurement computing library. The rest of these are available. It's diagnostic mostly. You're not typically going to look at that unless you're having trouble loading a driver. The center and the left, or the rightmost windows are diagnostic information for while you're running. And that's easiest shown as a demonstration when we get to that point. The very bottom, the last panel at the bottom of the screen, is the DASYLab status bar, or the status line. This includes information about the copy of DASYLab that you're running, and it includes information for the legacy driver. So this circle and this bar are associated with old drivers. And then it includes the current time, and this is a ticking clock. So going over it again, the top title bar of the application includes the name of the version of the DASYLab you have installed. So if you have DASYLab Full, it would say DASYLab 2020 Full. If you have Basic, it would say DASYLab 2020 Basic. Unknown in parentheses is the name of the file that you've saved. And then worksheet is the view that you are currently in. When you go look at the window menu, you can see that you've got 4 possible views. You've got a layout view, a sequencer view, a display view, and the worksheet view, which is your primary development area. The menus have the usual things in the menus. The file menu allows you to open, save, print. We keep a shortcut list of the last files that you've been running with. The edit menu includes the usual cut, copy, paste, delete. It includes a search function that's unique to DASYLab, and it includes some functions for the module bar, the layouts, black boxes, as well as a save the view of the worksheet to the clipboard. The module menu is unique to DASYLab, and it's a list of all the functions that you can use in your installed version of the program. This list is the same list that you see in the module browser on the left of the DASYLab screen. The measurement menu is also unique to DASYLab. This is the start. It's time control if you have DASYLab Net client-server communications. It includes a setting to do auto start. When I click that, it's a modal. You just toggle it on or off. If you are using the legacy driver, IoTech sound card, you would select the driver here, and the hardware setup is going to depend on the hardware that you have configured. I have the National Instruments driver loaded, and I have the measurement computing driver loaded, so that you can click here and open a dialog box that's unique to the driver that you're working with. So the hardware setup for measurement computing will be different than the hardware setup for National Instruments, which really don't give you a lot of hardware setup. So we let you set up the synchronization capability of National Instruments equipment. Also, there's measurement setup. This would set up the timing characteristics for your application, and the time-based dialog. These settings allow you to look at all the timing sources that are available to your version of DASYLab. So in my case, I have timing associated with DASYLab itself, the loaded driver, and I have right now connected a USB 2408 from measurement computing, and that has 2 input type time bases and an output time base. We'll go over more of that. We'll come back to time bases because That's a critical concept for a product like DASYLab. You also have the ability to configure serial devices. You can set up external device configurations. You can load them from files if you've already got a pre-configured device. The View menu allows you to look at an overview. It allows you to configure how DASYLab animates its screen, and it allows you to turn off different elements of the screen. We strongly recommend that if you don't want the information at the bottom of the screen, that you use the View menu and not the Resize feature. If you resize the bottom of the screen down to the very bottom, you may never be able to open it again without going into an INI file and changing some parameters. The View menu just lets you turn it off. That's called the information area, and you can just turn it off so that it doesn't show on the screen at all. When you're in development and working on a new worksheet, some of the contents of the information area can be handy. So I leave it on until I'm done and ready to go into production. The View menu also lets you turn off the function bar. It lets you turn off the status bar at the bottom of the screen. It lets you turn off the browser. And it lets you individually turn off the bottom elements. You can turn off just the console, or you can turn off the FIFO list and graph. So you can just turn off the FIFO list and graph. Now, one thing you should be noticing as you're looking at menus, that there are shortcuts indicated, keyboard shortcuts that are indicated for some of these different functions. The module bar for DASYLab does not display by default. We've tried to work away from using that. We would prefer that you use the module browser to find and add functions to DASYLab. You also have the ability to configure display windows, individual display windows such as chart recorders or digital meters. You can hide, show, minimize, and restore. You can do them as a total group, or you can do them individually. We'll come back to this in part 4 or 5, how to use save window arrangements. The Tools menu is a custom menu. You can actually add things to it. There's a short section in the help that tells you how to add things, and there is an external program that you can run from DASYLab that's called the Reference Curve Editor. The Options menu is where you define your global settings, default folders, default fonts, any hotkeys that you want to set up in addition to the DASYLab defaults. You can configure a wide variety of hotkeys. You can add your own if you would prefer. This is also where you would do global settings, including password definition, how you handle screen locking. You can get a list of actions in your worksheet. You can configure and view your strings and variables. Tucked down here is a function called copy channel names. And if you're working with the DASYLab script module, this is where you would create your script package. One final thing that you can do here, you can preview how your worksheet will look in the runtime mode, because the runtime display looks very different than the developing display. The window menu lets you switch between the views, and the help menu has the usual help stuff. It includes the contents, it includes examples, it includes the legacy hardware driver, as well as drivers for the or help for the drivers that you have installed. Patents, you can identify the monitor that you're on. You can see that this is the DASYLab monitor. And you can also get a report. So this is a report of DASYLab, and you can get the about for DASYLab. In addition to your user information, this includes the options that are configured, the manufacturer, in this case Measurement Computing, our contact information, and system information for what's installed on your computer. So DASYLab knows, or it knew when it started up, that I had 3 monitors connected and that I've got a total desktop size that is the combination of the 3 monitors. It also tells me how much memory is available and how many cores I have. So this is diagnostic information. Again, if you're having problems and you need to call us, we may ask you to load some of that information. So that's just menus. The next line is a shortcut bar. And the shortcut bar is, we call it the function bar. These are buttons that are connected to the menus. This is the start, pause, stop button associated with the measurement menu. The next group are the new, open, and save buttons associated with the file menu. The next three buttons are associated with the measurement menu. And you can see if you hover over it, will tell you what the buttons mean if you can't figure it out. I will come back, and the time-based setup is useful to look at because that's not an icon that jumps out at most people. It looks like a pyramid. Now, if I tell you it's a metronome, squint at it a little and go, oh yeah, that's a metronome. That'll make a little bit more sense to you. The fourth button in this group goes with the file menu. It shows you worksheet info. The next four buttons move you between the views, so you can move from the worksheet view to the display view to the sequencer view and back again here. Cut, copy, paste, black boxes, and then the view menu, restore all, hide all, show all, minimize all buttons are here. This drop-down is associated with window arrangements in the view menu. The help button, so this gets you to the contents. And then there are 8 buttons that you can configure to be anything you want. We predefine global variables, global strings, and the report function, but you can right-click on this and assign any button, any menu item to the button that you want. As I said, the left is the module browser. It also includes the navigator, which is a list of all the functions on your worksheet, a list of favorites that you can add to, and a list of black boxes that are available on your system. So this is the quick way to get to all the functions in DASYLab. You're going to use it like this. Let's make a quick worksheet. I'm going to create a measurement computing analog input from the input-output group. You can drag it and drop it. This module asks for more information, so I'll click OK. And I will click OK. And then I can go down to the display group and drag out a chart recorder and click OK to connect. And I'll do a quick touch and connect to connect these. The recorder comes with a display window. Right now it's minimized somewhere at the bottom of my screen. And there's a glitch in Windows 10 where you can't always see the minimized window, but you can always click the Restore All Windows button to have it restored back so that you can see it. This is called a display window. It does not have to be inside the DASYLab window. It can be anywhere on your monitor or monitors. Now, if you click Start, this is going to complain about sample rate. And now I'm acquiring data from a device that doesn't have any data connected to it right now. So this is just reading 0 coming in. But that's just the quick how the work area works, the fact that you've got standalone displays that you can restore or minimize, and that's working with the module browser. When you are running, so I'm going to click the Start button here, I'm running, you can see that there's an animation. There's a little red line that goes back and forth over a green line to show you that DASYLab is working. The faster it goes means the faster it's generating blocks of data. It's set up right now to generate data every 1/10 of a second, so it's toggling to give you an indication of that. You can see what's happening on that wire. If you click on the wire while you're running, you can see the data You can see a list of characteristics or values associated with that data channel, as well as a quick preview of what's happening in the data channel. So right now I'm looking at 9 samples at a time of the data. So this is 9 samples of my mostly zero data. So we refer to this line as a wire. Wires can be added and deleted if you right-click over a wire. So we're going to go up to this, right-click. It changes color. And then you right-click again to remove it. You can wire it by clicking on the output of the module that you want to connect from and connect it to the input of the module you want to connect to. And you'll know you're in the right place when you see the color of the number you're connecting to change from blue to yellow. When you click, it's going to draw a wire. When you move the modules around on the screen, the wires are going to follow an auto route. And in general, you want to use the DASYLab auto router. You also want to try to keep the lines as straight and neat as possible, because as your worksheets get more complex, there'll be more wires on the screen. You can also remove the wire by right-clicking over the module, for example, and say delete input connections. What else do I want to talk about here? Oh, I'm going to load an existing worksheet. I'm going to load an example from the example folder called signal analysis filter.dsa. I'm not going to save this. Now I'm going to move it down into a recording area. Hold on a minute. There we go. This is an example that we include in the example folder. It's a demo that was put together, I think, at one point for a trade show, and it includes a bunch of nice combinations of things. One of the things it does is it uses a generator to create data rather than reading data in from a device. It does filtering, and then it does a frequency computation and displays that data. I need to pause this for a moment to show you how it's going to look when it starts. Okay, so I've switched to full screen mode to show you what's going to happen when I do some different things. First of all, we created a drop down here that says normal. When I click on normal, this restores the displays that were configured with this worksheet. And you can see that they're up toward the top of the screen, which suggests that DASYLab was probably running up in the upper corner of a smaller monitor when this was originally created. If I click the Start button on DASYLab now, this worksheet is going to go into full screen mode showing you a layout. And the whole example is to show how the frequency and filtering will affect the signal as you filter it. So this is taking an input signal and filtering it. If you click the Stop button, DASYLab is configured to go back to the worksheet view and to show you the worksheet. So that was the layout. So the layout is a piece of paper or a screen where you configure only the elements of what you want to see. And you can configure DASYLab when you click Start to show you that in full screen mode. And now I don't see the Daisy or the Windows bar at the bottom. I don't see the Windows Start menu. DASYLab is on top, controlling the screen. So this is the layout view. If I click the Escape button, it takes the layout view into a windowed mode in the main DASYLab program. And now I can go to the window menu and go back to the worksheet view, and I can stop the measurement from here. So that's a rough overview of the DASYLab work environment. You have modules, you have wires that connect the channels, the output channel of a module to the input channel of another module. Each module, when you're working with it, has a properties dialog, so that if I right-click over the module and go to module properties, it's going to open up a properties box that's specific to the type of function. This is a generator that's creating an impulse function at 4 hertz with an amplitude of 1. If I look at the YT chart properties, these are different. The YT chart is a display window, so it has additional capabilities in here, including the ability to configure the x-axis and the y-axis. Each module will have different properties that you set up as you are setting up your measurement.
So coming back to my slides, when you're working with DASYLab, most manipulation is using the mouse. As you saw while I was walking through the program, I was able to find things in the menus, in the module browser, via the toolbar. If I had enabled the module bar, you would have seen that. And you can use right-click in a lot of different places. It doesn't hurt to try right-click in different locations on the screen to see what the context menu offers. If you right-click over a module, you'll typically see at least delete module and replace module, as well as the settings at the bottom of this context menu where it shows you search for the module default settings, module documentation, and module properties. So every module will have a similar menu, and it depends on how you click on it. If there is nothing connected, you won't get the opportunity to delete the input connections or the output connections. So as I said, the work area is where the modules are placed and the data flow is configured. You do that by connecting modules. In addition, as you saw on my filter example, the worksheet has the ability to include documentation. They are going to be rectangles that you put on the screen where you can type in some amount of information. It is only textual, alphanumeric. There's no pictures or other elements that you can add to these documentation boxes, but you do have control over the fonts, the colors, and the sizes and positioning of these boxes on the screen. If you use documentation, it will help you when you come back and look at something you worked on a month ago, 6 months ago, or a year ago to see what you did. I also use the documentation to sign worksheets. I'll put a block up there that says that I created it, and I will also keep a to-do list on my worksheet where I am and what I need to do next. So the module represents a specific function available in DASYLab. The modules are divided into a fixed number of groups. When you create a module, you can double-click on it or right-click on the module icon to open the property pages. So that's referred to as the module dialog box as I'm talking. Many modules can be expanded up to a maximum of 16 inputs or outputs. Modules fall into 3 categories: data input, output, or data processing. And then there are a couple of hybrid modules that may do a little bit of both. When you look at the module properties, typically the information at the top of the dialog box is going to apply to the entire module. So in the case of this chart recorder, how you zoom, how the time axis is defined, and how trigger events are handled apply to the module no matter how many channels are configured. The channel bar is the element that allows you to add channels to a function. They will always start with at least one channel, and if it allows you, you can go up to a maximum of 16 channels. There are no modules that have more than 16 channels. Below the channel bar are elements that are specific to the selected channel. and the selected channel is the channel on the channel bar in green. In this case, it includes the channel name and the unit for the channel. This module also includes additional buttons to be able to configure the module. So it will open additional dialog boxes where you can configure X scaling, the Y scaling per channel, reference curve information, and print options. The module browser is where you're going to see the functions grouped by type. If you can't find something, you can right-click over the browser to search for a module. And it's going to search by the name, and you need to know how to spell it. So if you're looking for average, type average. If you're looking for mean, median, or RMS, those won't come up because we don't have modules named that. Each function is only listed once, even if it could be in more than one group. My favorite example is the relay module, which is in the trigger functions group. And once you get to know DASYLab, you might argue with me that it really is a control function because the relay controls the data flow. But once we created it and we decided it went in the trigger group, we're not going to change it, nor do we replicate it. You can add functions to DASYLab, and the measurement computing and National Instruments drivers are examples where those menus only appear if that driver is loaded. So in the image that I've included here, the measurement computing driver has its own set of modules, and if you had not loaded the measurement computing driver, you would not see that subgroup there. The module browser has the 4 tabs: Modules, Black Box, Navigator, and Favorites. This panel was resizable so that you could increase or decrease the size of it, in addition to hiding it if you don't want to see it. So connecting and disconnecting module wiring. There are 2 ways to connect modules. One of it is to select on the output terminal and connect it to the input terminal. I'm also showing you different ways of deleting in this little animation. And the other one is kiss and connect or touch and connect to be able to quickly connect the wires. So this is just a cute little animation to show you some of the different ways of manipulating the wires. So in words, wires are used to connect inputs and outputs of modules. If it's on the right, it's an output. If it's on the left, it's an input. There are no terminals on the top or bottom of DASYLab modules. To add a wire, you click on the module output and connect it to the receiving module's input. You can do the drag and drop KISS modules together to automatically create the wires. I think I showed you can click on the wire and view data in the information area at the bottom while you're running. And just to say it again, to remove a wire, it takes 2 right clicks with a pause in between. So it's not a double right click, it's a click to select and a click to delete. Menus are menus. I talked about menus the first time through, so I won't beat it to death. Where are my files? DASYLab defaults folder locations to the public user folder on your computer. If you want to change the default location of where those folders are on your computer, once you've installed DASYLab, in the DASYLab configurator, which is part of installation initially, you can change the location of the default folders to any other folder on the computer. And when you are in DASYLab, you can go to the Options menu, Default Folders, and change the locations. So we have locations for worksheet, streaming, data, devices, black boxes, and other. And it's mostly the worksheet and data folders. These are the default locations. Of course, you can do a file save as or a file open of any file available to your computer. So we are conforming to the Windows folder requirements, which does not allow us to store any data with the DASYLab program itself. We chose to put the user data files in the public folder, and each version installs into a folder based on the version number. So if you have a version of DASYLab and you install a new one, a new revision, then we're going to create a new group of folders. Only the user data folders are in this folder. In this release, read-only files, which include the examples and manuals, they are in the program files folder. The black box, data, devices, other worksheets, and data are in the public folder. And this just shows you the progression of the public folder name from DASYLab 13 to DASYLab 2016, DASYLab 2016 Service Pack 1, and then DASYLab 2020 is going to store in the DASYLab 15 folder because that's the actual version. All right, let's talk a minute. Sampling. This is, again, vocabulary, but it's also a concept. We're working with taking data from the real world and moving it into the digital world. And in order to do that, we are going to be sampling the real world analog signals and creating discrete sets of data to represent that analog signal. So in signal processing, sampling is the reduction of a continuous signal to a discrete signal. The common example is the conversion of a sound wave to a sequence of samples. And sample can also refer to a value or a set of values at a point in time and or space. In DASYLab's context, it's usually at a point in time. Sample rate, sampling frequency are interchangeable terms. The number of samples per unit of time. With most data acquisition, we're usually talking seconds. Seconds or fractions of seconds is the sample rate. The sample rate in the time domain, the unit for sampling rate is hertz, which is inverse seconds, 1 over seconds. It's sometimes noted as samples per second to distinguish it from the frequency of your acquired signal. The inverse of the sampling frequency is the sampling period or the sampling interval, which is the time between samples, also noted as seconds. An example for this would be if you're sampling at 100 samples per second, your sample interval is going to be 10 milliseconds between samples. You really can't do data acquisition without understanding some of the constraints. And the constraints, particularly around frequency analysis and acquisition, we're going to use this to tell you how fast to go. The Nyquist theorem says that an analog signal waveform may be uniquely reconstructed without error from samples taken at equal time intervals. The sampling interval, or the sampling rate, must be equal to or greater than twice the highest frequency component in the analog signal. So a bunch of concepts in here. One of those is samples are taken at equal time intervals. So this says that if I have acquired data with samples taken at equal time intervals, that I could reconstruct that signal. But the sample rate had to be equal to or greater than twice the highest frequency in the signal. I've got an image here that shows in blue a 2 hertz sine wave that was sampled at 3 hertz, which is less than the Nyquist frequency. The Nyquist frequency would have been 4 hertz. And what you see is that the sampled signal doesn't look like the signal that it was sampled against. The frequency is wrong, the shape is wrong, the amplitudes are wrong. We're not getting the peak amplitude at all. So this is an example of what happens if you undersample your data. Oh, I'm aliased here. Look at that. If the sample condition isn't satisfied, frequencies are going to overlap. So aliasing is a concept that says if you are acquiring data from the analog domain and there are high frequencies in the domain, think sound in particular, that if you sample sound and there are high frequencies in the sound, it's possible that those high frequencies will get acquired but look like lower frequencies because you undersampled them. So it causes different signals to become indistinguishable or aliases of one another when sampled. To prevent aliasing, you can increase your sampling rate to at least twice the highest expected frequency, or you can introduce an analog anti-aliasing filter or make an anti-aliasing filter more stringent. Now, this is analog so that it is applied before the data is digitized. The anti-aliasing filter restricts the bandwidth of the signal to satisfy the sampling condition. It's like many of these things in theory, but it's not always realistic. A signal will always have some energy outside your bandwidth, but what you're trying to do with an anti-aliasing filter is reduce that energy to the point that the aliasing effects are negligible. So I always summarize by saying you need to collect at a high enough sampling rate to effectively view and analyze an analog signal waveform. If you have a sine wave and you only sample it at twice its highest frequency, you won't see what it looks like. All you'll see is the amplitude and the frequency, but you won't see how it rises and how it falls. Typically, you want to sample at least 10 times the highest frequency in order to visualize the waveform. And that's going to depend a lot on what you're measuring. If you're measuring something that is changing or has a lot of noise, you may find that you want to sample at higher rates. So the rate's determined by the bandwidth and the highest frequency component of the waveform, at least twice. More typically, with a product like DASYLab, you're going to sample at 10 to 20 times that highest frequency to be able to visualize the waveform. So now this is DASYLab. Sampling rate is physics and mathematics. But sampling rate is something you're going to choose based on the measurement that you are doing. If you are sampling temperature, you're going to sample anywhere from 1 to 10 times a second. If you're sampling sound in the audible range, our hearing range, or using the Windows sound card, you're going to sample at about 11,000 samples per second to be able to see that. If you're doing music where you've got higher and lower frequencies, you may be sampling at 45,000 samples per second. It totally depends on what you're measuring and how you're measuring it. And that's not anything we're ever going to give you a firm answer on. It's the physics of your measurement task. Now, we're in DASYLab. We're going to now implement a constraint for you. We need to be able to manage that data in a way that we can process the data efficiently without bogging the computer or the DASYLab program down. And we do that by using blocks of data, in effect an array or a vector of data, that we are going to suggest strongly that you choose a block size to match the computational requirements of your application. The default is going to depend on the driver. It is typically 1/10 of the sampling rate. So that if you set up a brand new measurement computing device at 1,000 samples per second, we will default the block size to 100 samples per second. So you're going to see 100 milliseconds, 1/10 of a second at a time. And every second we will get 10 blocks of data. Turns out that's a sweet spot for DASYLab, about 100 milliseconds worth of data at a time. This also gets us into another tough concept of a program that has been around for a while. We have 2 driver models. We include drivers from many vendors, and each driver will have its own measurement and hardware settings. We support multiple time bases. Depending on the driver and the developer, and the capabilities of the device, it may have one time base. Those are your timing settings, sample rate and block size. Or it may have two, or in the case of that USB 2408, it had three. The older driver model that I will refer to as the legacy driver model includes the sound card driver, and it also includes devices from IoTech. So if you have a IoTech DAC book or an IoTech Personal DAC 3000, you will be in the older driver model, and you will use the driver menu settings to configure your device. If you have a National Instruments or data translation or a measurement computing device, then you will use those menus. So you use the MCC menu for measurement computing, the NI menu for National Instruments. The measurement time bases puts all the timing information into one dialog box so that you can see all the timing sources that are available on your system, as well as to be able to change them all in one place. Drivers that are loaded as the driver use the measurement driver settings, and we have two shortcut buttons for the old legacy driver, and that's the button that's labeled A/D and the button that is the green PC card looking board. I'm sorry about this slide. So drivers loaded as driver use the measurement driver settings, and there's only one driver allowed at a time. So you're only going to have the demo driver or the sound card driver or the IoTech driver. Drivers loaded as the extension driver will have their own submenus in the measurement and hardware menus. Measurement, MCC, NI, Instranet, data translation will each have their own menus. You can use multiple extension drivers at the same time. So as you saw, I had both National Instruments and measurement computing loaded. If I had any data translation devices, they would have been loaded. So you can work with multiple devices using similar functions in the same worksheet. Extension drivers create their own input-output menus, as well as their own measurement menus. So I mentioned blocks. This is why we care about blocks. The DASYLab worksheet is a data flow diagram. DASYLab transports data in the worksheet from left to right, so from source to sink, blockwise from module to module. So a module will acquire the data or generate the data in the case of a generator, and it will create a block of data and will output that to the next module when the block is filled with data. The size of the data blocks and the sampling rate are going to determine the overall processing speed, which in turn determines the data flow in the block diagram. The maximum block size is 1,048,576 samples, and the minimum block size is 1 sample. Here's why we care. If you have a worksheet with 100 modules, so you've got some complex logic and a bunch of channels, and your sampling rate block size ratio is 1,000. So for example, you're collecting at 1,000 samples per second with a block size of 1. DASYLab has to process 100 modules in a millisecond. That leaves each module 10 microseconds to process its data. Now generally, these computers are pretty good these days. At some point, depending on the complexity of the worksheet and the functions, DASYLab may not be able to keep up, falls behind, and stops because it doesn't have enough time to do things. It will end up with some sort of data overrun or data block kind of error message. The greater the sampling rate block size ratio is, the more often the worksheet gets updated. So if you've got this sampling rate block size ratio, your worksheet will get updated 1,000 times a second. That starts to be bad. We want you to use a sampling rate block size ratio of 1 to 10. We want the worksheet to update typically no more than 10 times a second. Now, there's some flex in there. It's going to depend on your PC and what else you're doing. You may find that you are happy with 1 to 1 because you're doing temperature. You may be happy that you can do 25 to 1. 1 to 25. That may be fine. That's going to be something that you're going to have to test. So a little bit more. This is still very theoretical because we haven't played with anything really yet. The default block size depends on the driver. If you've got an IoTech device or you're using the sound card driver, the block size will be half the sample rate rounded to a power of 2. So 1,000 samples per second, the block size would be 512. At 10,000 samples per second, the block size would be 4,096. So it's going to be half the sample rate, 5,000, and then rounded up or down to the next power of 2. And 4096 is closer than 8192. Again, I'll keep repeating this. The smallest suggested block size is a tenth the sample rate. If you are working with PID control, the PID requires a block size of 1. The state machine module also requires a block size of 1 because it's a control function. That's going to limit the overall sampling rate to less than 10 samples per second. So the time-based and driver settings are several submenus down from the main menu. You can use the menu shortcut function to map a button to one or more of the measurement menus. And the legacy driver modules have the predefined function bar buttons. So let's talk about doing menu shortcuts. So those 8 circles with numbers in them, 1 through 8, can be mapped to any function on a menu. Right-click over, in this case, the number 5, choose Assign Button. It will pop up a dialog that will list all of the menus, and you can drill down into the menu until you find the function you want to assign. And what I've shown you is going into the measurement menu hardware setup for the MCC DRV hardware settings. This is per computer. If you're working on a worksheet and you move the worksheet to a different computer, the shortcut buttons don't go with you. So that's the introduction. The next step is to jump in and start doing some hands-on exercises. Each module is going to run 60 to 90 minutes. Module 2, we're going to talk about doing a data logger, saving data, doing one channel with scaling, adding a second channel, and then replaying some of the data that you saved. Module 3 will start to introduce controlling the data flow using triggers, switches, and the relay module. And we'll also do some straightforward mathematics and statistics to introduce you to those functions. We may do, depending on my hardware here, digital inputs and digital outputs. Because that's actually working physically with the hardware, I may skip over that. We'll see when I get to finishing that. Module 4 will cover signal analysis, frequency analysis, and then we'll start to introduce visualization, global strings and variables, and actions and events. Module 5 will be focused completely on visualization, how to make your worksheet look nice with layouts, using multiple layouts, configuring the layouts, and using actions and events to manage your layouts. Module 6 will use that concept and move into strings and variables, and then branch out to go back to the file module to talk about how to create custom file names now that you know about strings. And we will do advanced layouts with strings. Module 7 will cover the black box documentation using the message module, so it's sort of a miscellaneous collection of topics. And then Module 8 will be miscellaneous topics. And when you start it up, we'll have a menu of what you'll be able to look at there. Thank you very much for your time. I hope you continue with the class. Give us some feedback. Was this terrible? Was this good? We appreciate hearing from you. Thanks.